Extended or subtended from the center. All right, so this is what a sector is. Now, what is an arc? An arc is simply a part of the line through which the circle is drawn. The line through which the circle is drawn. So a part of which, why the circumference is simply a part of the circle. This part is the circumference. An arc is simply cutting out a part or a part that has been removed from the circumference of the circle. That's what an arc is. So I think I've explained this. I've explained this chord, sectors, arc, and circumference. Yes. So I guess we are good. So there's one other thing, segment. Segment is simply a part that connects two sides of a radius and a chord. So for example, I'm going to redraw this. I have a chord here. This is the center of my circle. The segment here is simply the line that so all right. So this is once I explain this segment, I'll come back to this. So a segment is two lines that is simply a part of a circle that joins a chord and the radius of a circle. The part of a circle that joins the chord and two radii in the circle. So this is a radii. This is another. This is a radius, and this is another radius. So these two radii joining with this chord is what gives a segment. These two radii and this chord is what gives a segment. So this part here is a segment of the circle. So I've explained sector as a part of a circle that is being cut out, a part of the circle that is being cut out from the actual circle. Take, for example, your orange. Your orange, when you cut your orange into a different shape. Let me say you divide the orange into two, and after you have your half, you divide that half into two to get a quarter. You're going to have something like this. So this is the sector, and the sector is always subtended at a particular angle to the center of the circle. So this is sector of the circle. I explained arc as a line on the circumference of the circle, a particular line or part on the circumference of a circle. So this is an arc. This is also an arc. while circumference of a circle is the part at which a circle is drawn, the part on which a circle is drawn. So I've explained diameter as a straight line passing through the center of a circle to toss 2 points on the circumference, while radius is a straight line that connects from the center of a circle to any point on the circumference. So those are the properties of a circle. All right. So we can now move to the we'll move to the, if you can hear me, please. Can you indicate if you can hear me clearly? Hello guys, can you hear me? All right, so we'll move to working examples. We'll pick working examples from the past question. So the question says the length of a sector of a circle. So I'm going to draw out a circle. The length of a sector of a circle is 33 centimeter. Find the angle it subtends at the center of the radius if the circle, sorry, find the angle it subtends at the center if the radius of the circle is 14 centimeter. So we are given a circle. The question says the radius of the circle is 14 centimeter. Let's say this is 14 centimeter. The radius of the circle is 14 centimeter. Now the question is asking us to find the length of the arc of a sector that is subtended, that is 33 centimeter. We have to find the angle at which this sector is subtended to the center. So this is 14 centimeter, the radius of the circle, and we are asked to find the angle at which this sector is subtended to the center of the circle. The question says the length of the sector is 33 centimeter. Now, how do we find the length of a sector? So to find the length of a sector, we use the formula. So actually, it is the length of the arc in the sector, the length of the arc in the sector. So where's the length of the arc from this point to this point? This is 33 centimeter. We have a formula that we use for it, which is theta over 360 times 2 pi r. What is theta? Theta is the angle at which the sector is subtended at the center. Pi is 22 over 7. YR is the radius of a circle. So if we are going to use this parameters, we'll have theta over 360 because theta is unknown. I don't know the angle yet. That is what I'm to find in the question. So I'm going to do theta over 360 times 2 times 22 over 7 times 14 is equal to 33. Why did I say 33? Because 33 is the length of the arc of the sector. All right, so I can do arithmetics. This, I have theta over 360 times 2 times 22, 44 times 2, 88 is equal to 33. So yeah, I have 88 theta over 360 is equal to 33. So yeah, I can cross multiply to have 88 theta is equal to 33 times 360. And then here I have theta is equal to 33 times 360 divided by 88. So yeah, I'm going to do my division by arithmetic. 33 times 360 divided by 88, multiplication and division to get your answer. So if you do that, so yeah, I think 11 is common. So I have 3 here, 8 here is, so if you divide 360 by 8, you should have 45. So you have 3 times 45. So 3 times 45 is going to give you 135. So the answer is 135 degrees. So you guys can confirm this. 33 times 360 divided by 88 should give you, yes, 135 degrees. So you have your answer as 135 degrees. 135 degrees is the angle subtended by the sector at the center. 135 degrees. So that is option D in the question. Option D in the question. So we can continue and find, let's say the question asks us to find the chord, the length of the chord of that sector. The question asks us to find the length of the chord of that sector. How are we going to go about it? So firstly, what we are going to do is, if we want to find the length of the chord, this is from here to here. We can, from last class, we treated Pythagoras theorem. So we can use Pythagoras theorem to find the length of this, because this line here, this vertical line, is dividing this chord into 2 equal parts. So which means if we can get the length of this, it means the length of the chord will be this times 2, right? So let's label this as L. So which means if I can get the value of L, it means the length of the chord will be 2 times L, which is 2L. Now let's see how we can do that. If we draw out what we have here, what I have here, this becomes a right angle triangle. And from the last class, we know how to use Pythagoras theorem to solve for each sides of a right angle triangle. So here is 14 centimeter. All right. We just calculated that the angle subtended at the center is 135 degrees. So if I'm dividing this into 2, because this vertical line is dividing this particular triangle into 2, all right, it means this angle here will also be divided into 2. So this part here will be 135 divided by 2. And 135 divided by 2 is 70, or rather 67.5, right? 67.5. So the angle here is 67.5. So I'm to find this, which I labeled as L. So now, firstly, we have to label the sides of um our triangle correctly. This is hypotenuse, right? This is opposite, while this is adjacent. Now I need to find the value of my opposite, and I know the hypotenuse. So I'm going to write out my 3 trigonometric functions, so katoa. My 3 trigonometric functions, sine, cosine, and tangent. So here I have my hypotenuse, and I'm looking for the opposite. So which of these trigonometric functions uses opposites and hypotenuse in evaluation? Which of these trigonometric functions uses opposite and hypotenuse in evaluation? It is sine. So which means sine theta is equal to opposite over hypotenuse. Sine theta is equal to opposite over hypotenuse. What is my opposite? Firstly, my theta is 67.5. So I'll say sine 67.5 is equal to opposite is L over hypotenuse. All right. So I'm going to repeat the question. The question says the length of a sector. I'm going to repeat this slowly. So if you guys want to write it, you guys can write it down. The length of the sector of a circle find the question is okay. So if you've written the first question, so we're still working on the same question. We're just finding the chord. So let me just repeat the question. The length of the arc of a sector, Jesus. The length of the arc of a sector of a circle, right, is 33 centimeter. Find the angle it subtends at the center. If the radius of the circle is 14 centimeter, find the angle it subtends at the center if the radius of the circle is 14 centimeter. So that is what I illustrated. Your question is what I illustrated in this diagram. So now we've calculated the first part of the question, which says calculate the angle it subtends at the center. Now I'm not going ahead to calculate the length of the chord extended by that particular sector, the length of the chord extended by that particular sector. So that is what we are working on now, which I'm using this Pythagoras theorem. And this is where I started the solvings for that. So this is the workings for the first question, angle subtended at the center. And this is the workings for the second question, second part of the question. So I'm saying opposite over hypotenuse is sine, right? So I say sine 67.5 is equal to opposite is L, which I denoted as L over here, over hypotenuse, which is 14. So I need somebody to tell me the value of sine 67.5 real quick. Somebody should unmute and tell me the value of sine 67.5. Hello, sine 67.5.
.9.
So I need you to give me the answers in 4 decimal, please.
is 0.939.
0.9234.
0.9234. Can you come again? 0.92.
0.9239.
So I'm going to multiply that by, I'm going to cross multiply and say L is equal to 14 times 0.9239. So you can do the multiplication 14 times 0.9239. So what do we have? We should have 12.9346 centimeter. So if the question is given in 3 decimal place, you can convert to 3 decimal place. If it is in 2 decimal place, you can approximate to 2 decimal place. While if it is a whole number, you can approximate to whole number regardless. So this is the value of L, but we are not done. We have to find the length of the chord. And I said the length of the chord is 2 times L. So if this place is L, this place is L, it means the length of this chord is L plus L. So now to get the length of the chord, I'm going to say 12.9346 times 2. So that will be the length of the chord extended by this particular sector. So I have, this will give me, if I multiply this by 2, I'll have 25.8692. So I will prefer to leave this in 3 decimal place. And I have 25.869 centimeter. That is the length of this chord. So if you have questions, you can ask before we move on to the next question. Right. So in absence of no question, I'll move on to the next question so we can solve this together. So if you have your past question, it is on page 64, number 3 of your past question. Page 64, number 3. So here is the past question. So page 64, number 3. This will be the past questions we'll be working with throughout this each classes. So yeah, question is number 3. A chord AB of length. Okay, let me explain this so I can do the illustration on the board here. So a chord AB of length 10 centimeter. So I'm going to do this first. I'm going to draw the chord. This is A, this is B. Remember I said chord is a straight line that touches 2 points of the circumference of the circle without passing through the center of the circle. It touches 2 points on the circumference of a circle without passing through the circumcenter. All right, so a chord AB of length 10 centimeter. So this is 10 centimeter. Is placed in a circle of radius 8 centimeters. So this is a circle, and this is the center of the circle. Now, as you can see, my chord is not passing through the center of the circle, so that makes it a chord. If it's passing through the center, it becomes a diameter. All right, so the radius of the circle is 8 centimeters. Now, remember I said the radius of a circle is the length from the center of the circle to any point on the circumference of a circle. So which means from here to here is 8 centimeters. This point on the circumference, 8 centimeters. It also means from here to here is 8 centimeters. All right, it says calculate the angle of the chord subtended at the center of a circle. Calculate the angle of the chord subtended at the center of a circle. So this is what we are to calculate. So I'm going to name this as theta. So now from here, if I draw out the triangle we have in this circle, I'll have something like this. So if I draw this out, I'm going to have a triangle. And what type of triangle is this? What type of triangle is it if both two sides are equal? A triangle with two sides being equal is called an isosceles triangle. And what's an isosceles triangle? An isosceles triangle means the two base angles are equal and two sides are equal. The two base angles are equal and two sides are equal. So which means these two base angles, these two guys here, they are equal. So here is x and here is x. So if this place is 30, this place will also be 30. If this is 45, the angle here will also be 45. That is an isosceles triangle. The two bases, the base angles are equal and two sides are equal. So we have the two sides equal. It means the base angles will be equal. That's an isosceles triangle. So now we have to find theta. So we can go about it in different ways. We can actually use the Pythagoras theorem to draw out a we can use Pythagoras to draw out a right angle and then use our trigonometric functions to find the value of this angle. Or we can also use trigonometric functions to find the value of this angle and then multiply it by 2. Either ways, we'll still get the same answer. So we'll do it both ways and see if we get same answer. All right, so this is x. This is x. So I'll do the first way. So I'm going to name this part y, right? This half part here of this angle, I'm going to name it y, which means this place will also be y. So if I get the value of y, it means the value of the angle subtended by the chord is 2y. That's 2 times y. So I'm going to do this. Drawing this out, it means because these vertical lines divide this base, this will be 5 centimeter. This is 8 centimeter. Now this is my y. This is my x. So because I'm using y as a subject of reference, y is my angle of reference, right? This is going to be my opposite. This is hypotenuse, and this is going to be my adjacent. Because y is my angle of reference, right? This is opposite, and this is adjacent. So now I'm going to use the sine function because this is opposite over adjacent. So I'm going to say sine theta is equal to opposite, which is 5 over adjacent. 5 over 8. Somebody tell me the value of 5 over 8. You do 5 over 8 on your calculator. What should you get?
0.65.
0.625. Right. Now to get the value of theta, right? To get let me come over here.
Adjacent is hypotenuse.
So to get the value of
5.
theta, you will do the sine inverse of 0.625. All right. So to get the value of theta, you're going to do the sine inverse of 0.625. So this becomes theta is equal to sine inverse of 0.625. Now somebody should calculate the sine inverse of 625. What do you have? So how you use sine inverse?
0.6.
Okay, you say
0.6. Is it in 4 decimal place?
the sine
The
inverse of
answer.
0.625.
Okay, 0.6665.
No, the sine inverse of 0.625 won't give you a decimal, won't give you 0 point.
Oh,
The sine inverse of on your calculator is you press the shift and the sine function. Shift and sine
okay.
function, then 0.625. So you should get something around
38.682.
38.
0.682.
All right, that's correct. 38.682. So the value of theta here is 38.682, which is y that we calculated here. So if I'm going to do that, I'm just going to work because this is degree. I'm going to work with 2 decimal places. This is 38.68. So I'm going to multiply it by 2 to get the value of theta here. You know, we calculated for y. So this is 38.68 times 2. What is that going to give us?
77.36.
77.36. Now, from what I'm seeing on the past question here, all the options are in 1 decimal place. So which means I have to convert this to 1 decimal place. So this will become 77.4 degrees. 77.4 degrees, option B. Now, option C. Now, if you look at the options in the question very well, you'll find out that there is an option that says 38.7. So if you stop at this place and you say 38.7, you actually have a correct answer. But if you stop at this point, right, you see an answer in the option that correlates with what you worked with, but you are wrong because you've not gotten the final answer. So the final answer here is 77.4. So if you stopped at this point, you actually see an option that correlates with your answer, but it is not the correct answer. So don't let that confuse you. Make sure you take your time and finish your workings, and then you get 77.4, which is the correct answer, option C. 77.4. Now let's see if we work with the second method, if we'll get the same answer.
I can't hear you, please.
All right, so I'm saying this is, I think I was muted. Sorry about that. Okay, so number 11, it's showing on your screen right now of the past question. This is Unilag Foundation past question. So we are on page 2, number 11. If you have that, you can open it, but if you don't, it is still on the screen, number 11. So this is an exercise. I need you to work on it right now in the next 2 minutes before we move on. Two parallel chords are respectively 48 centimeter. All right, so in while we are working on the exercise, somebody asked the question on the chat section. It says, why did I multiply the 38.682 by 2? All right, so if you are the one that asked this question, I want you to pay attention. So if you watched what we did here, you will find out that we divided this isosceles triangle. I called it an isosceles triangle, right? We divided it into two equal parts. So dividing it into two equal parts, we had this right angle triangle. So now in this right angle triangle, we had y as our degree, right? And we have 8 and 5. So what I did here is I solved for y. All right. So now after solving for y, the value of y is what is 38.682. Now for me to calculate the angle subtended at the center, which is theta, I have to do y, which is this first part, plus this second part, which is also y, and add it together. Y plus y. 38.682 plus 38.682. Or I say 2 times 38.682. So that way I got 77.36. And then in one decimal place, I have 77.4. I think that's clear. So I'm multiplying it by 2 because I divided the initial triangle into two equal parts and then calculated the first angle. So now for me to get the real value, I have to multiply back by the one I divided into 2. So that's why I'm multiplying it by 2 to get 77.4. So I hope that's clear. All right, so we have 5 minutes before the end of the class. I need you guys to produce the solution to the exercise in the next 2 minutes. Two parallel chords are respectively 48 and 40 centimeter long. Give the radius of a circle. Okay, so let me just help you guys out with an illustration of the diagram. So two parallel chords. Parallel means they are moving in the same direction. So this and this. So one of them is 48 centimeter long, while the other is 40 centimeter long. If the radius of the circle is 25 centimeter, this is radius. So here is 25. And the center of the circle lies between the two chords. What is the distance between the two chords? So here is also 25. So what they are asking us to find is the distance between the two chords. From here to here, this particular line, the distance between the two chords. So this is also 25. This is also 25 because these are all radius or radii of the, they are all radii of the circle. So how you go about it is you find the length of this. So the best way you can do that is draw out a right angle triangle. You calculate the value of this vertical height. You calculate the value of this vertical height. You add it up together, and then you have the distance between the two chords.
Sorry, please. What is the length of the chord again? The two chords.
It is on the question. The question is there on your screen. So what I just did is an illustration of the question. So the two chords, 48 and 40. So you have to find the distance between the chords. So I'll be expecting your solutions, sending your solutions as image on the WhatsApp group. I'll be expecting your solutions. You solve done, you snap and send in the next 15 minutes. You snap and send on the WhatsApp group. All right. So in that case, enjoy the rest of your day, guys. And yeah, before we go, if you have any question, you can just ask them real quick. I think we have 1 minute more. If you have any question, real quick, real quick. All right. Since there's no question, I believe you guys understand that. See you guys